Hi, Integrated Math 1. So today we're just going to go through our review worksheet from Unit 2.1 on linear functions. So I know you guys have the answer key available to you in Google Classroom, but sometimes it's nice just to have somebody explaining it. So let's go ahead and jump right on in. So question number 1 is asking us to rewrite the explicit formula in function form. So explicit formula is that whole a sub n stuff, but I don't want a sub n, I want function form. So I want it to be all like f of x and pretty and whatnot. And in fact, general form of the function form is what we're usually used to, right? Ax plus b, where a is our slope and b is our y-intercept. So the first thing I'm going to do is I'm going to change this. Instead of a sub n, I'm going to rewrite that as f of x. I still have my -3, I still have my +5, but now instead of n minus 1, no, I changed my n to an x. So I'm going to make that x minus 1. And now this is just a matter of cleanup. So I'm going to start by using distributive property. I will distribute my 5. So I now have 5x, 5 times -1 is -5. I still have that -3 up the front, my plus sign, and I still have my f of x. And now I'm just going to combine my like terms because check it out. I got a -3, I got a -5. So magical. So I'm going to do this, f of x equals. Now I like to have my slope attached to that x value up the front. So I'm going to move that 5x out in front. And then I'm going to combine my like terms. So a -3 and a -5 together gives me a -8. 3 negatives and 5 more negatives. And there we go. There it is in function form. So magical. This one is asking us to calculate the average rate of change for the function. Can you please remember that this is code for slope? You know, average rate of the change of the function just means find the slopes. So we're going to find the slope. You also know that you find the slope by subtracting your y coordinates on top and subtracting your x coordinates on the bottom, right? Rise over run. So just pick any 2 points on the line, any 2 points that you like. I'm going to pick this point because it seems nice and easy, right? The coordinates for that are 0, 1, right? No right or left, but I did go 1 up. I know it looks like 2, but it's labeled 1. I'm going to pick another nice and easy point to use. That one gives me halvesies. I don't want to do halvesies, so I'm going to keep going, keep going. Ooh, here's a good point. This is a great point to use because it comes over 4 and down 2. So again, great point to use. So now I have 2 points. So I will subtract my y coordinates on top. So I've got 1 minus my -2. So y coordinates on top, and I'll subtract my x coordinates on the bottom, 0 minus 4. Just to clean up, remember we don't like to minus a negative. The opposite of a negative is a positive. So I'm going to rewrite this as 1 plus 2, still over 0 minus 4. And now that's a lot easier to work with. Of course, 1 plus 2 is 3. 0 minus 4 is a -4. Can't simplify that. Always simplify if you can. I can't simplify this one. So I'm just going to leave it. There we go. There's my average rate of change. Yay. Also known as the slope. Let's take a look at number 3. Determine whether the table of values represents a linear function. If it represents a linear function, write the function. If it does not, explain why not. Okay, so we know in order to be a linear function, we have to have a constant rate of change, a constant slope. That's what makes it linear. So let's make sure that we're getting the same slope every time. Now, some of you guys learned this trick, and it's not a terrible trick, but we're going to find all the differences in the y's, all the differences in the x's, and then we'll use that to find our slopes. Because remember that slope is the difference in your y's over the difference in your x's, just like we were talking about. So 16 to 10, I went down 6. 10 to 4 means I went down another 6. And 4 to -2 means, yeah, I went down another -6. But that's not enough. I need to check my x's as well. I need to make sure that the slopes match. Let's check our x's. So let's see, -4 to 2 means I actually went up 2. I actually added 2. Negative 2 to 0 means, again, I actually went up 2. I added 2 to get there. And 0 to 2 means, yeah, I added 2 to get there. So let's check all of our slopes, make sure they're the same. So difference in the y's over the difference in the x's. Well, the difference in my y's is negative 6. The difference in my x's is 2. And we do need to simplify. Negative 6 divided by 2 is 3. We'll do it again. The difference in my y's for the next set of points is negative 6. The difference in my x's is still 2. And so I still have a slope of negative 3. Oh, those are negatives. Sorry. That's a good sign, but we need to make sure it matches again. So we'll do it one more time. The difference in my y's is negative 6. The difference in my x's is 2. And so sure enough, my slope is negative 3. So check it out. I got the same slope every time, not just the same differences. I got the same slope every time. That's what we got to check. So because I got the same slope every single time, because I have the same slope, I know that this means that my function is a linear function. Yay! Well, I've answered the first part of this. If it represents a linear function, which it does represent a linear function. Oh, I need to write the function. Okay, great. So I've shown my work, determine it's a linear function. Let's write the function. Again, you can think of it as f of x equals ax plus b. That's a general form of the function. Some of you guys like to think of it as y equals mx plus b. Both ways are fine. Just remember that's your slope, which we just found. And of course, this is your y-intercept. Don't forget that the y-intercept is where x equals 0. Your y-intercept is 4. There it is. Yeah, the y-intercept is where x equals 0. So here's where x equals 0. So my y-intercept must be 4. So that means I've got a slope. I've got a y-intercept. So my function is y equals, sorry, my y disappeared, y equals negative 3x plus 4. If you did f of x equals negative 3x plus 4, also correct. Both ways of writing it, fine by me. Elena is paid a constant rate for each hour she works. The table shows the amount of money that Elena earned for various amounts of time that she worked. Determine the average rate of change for the problem situation. Be sure to include units. Yeah, you've got to have your units on this. So average rate of change, again, we've said this many times. That's our slope, right? That's our slope. That's our whole subtract our y's on top, subtract our x's on the bottom. Do you feel like this keeps coming back to us? Because it does. You can pick any 2 points you like. I don't really care. I'm just going to pick the first 2. I'm going to use this guy and I'm going to use this guy. Hooray! So let's find our slope. Let's find our average rate of change. So I'm going to subtract my y coordinates on top. I'll do 27 minus 2250. It doesn't matter which one is first. But if I do 27 minus 2250 on top, I have to do 3 minus 2.5 on the bottom. I'm also going to bust out a calculator because I could do it in my head. I don't really want to do it in my head. So 27 minus 2250 means I get 4.5 on top for my numerator. 3 minus 2.5. I guess I don't really need a calculator for that one, but I get 0.5. And let's go ahead and divide this out. 4.5, again, using my calculator, 4.5 divided by 0.5 gives me 9. Now, it did say to include my units. Well, this is how much she's getting paid, right? And you can see it's my y is in dollars. My y is in dollars. My time is in hours. So that means this is going to be $9 per hour. Yay. So she's getting paid $9 an hour. That can be a little rough. Maybe she's got another job. Maybe she's living rent-free with her parents. I don't know. It's possible. I don't know where she works. Let's go over to question number 5. Malik received a $300 gift card from his grandparents and is using it only to pay for his karate lessons, which cost $30 per month. Now, they gave us the function, which is very nice of them to do. The function g of t equals negative 30t plus 300, and it describes his gift card amount, g, in dollars, right? You had a $300 gift card, as a function of the time t in months. So each month he's spending $30 for his karate lessons. Fair enough. Ooh, we're asked to write the function in factored form. Right now, this function is in general form, right? Right now, we're in general form. Talked about this in the past. So general form, which is the whole like f of x equals ax plus b, right? Here's my slope, here's my y-intercept. We've actually already used this a couple times today. But now we want factored form. Remember when we're talking about factored form, it's called factored form because it literally factors out the slope, right? So that means factored form factors out the slope. And so now I have my slope and my x-intercept. Remember, that's what factored form did. Well, right now my slope is negative 30, but I need my negative 30 to be factored out. So I'm just going to divide both of these by a negative 30 to factor it out of my equation. So I still have g of t. Now my negative 30 is going to go out front, and we'll do some division. Of course, negative 30 divided by negative 30, that cancels out, and I just have t. That's why we did it. That's exactly why we did it. And then over here, you're welcome to use your trusty calculator to double check. But 300 divided by a negative 30 is a negative 10. Oh, look, it's in factored form. Dun, 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 dun. Good job. Yay. That wasn't so bad. Next. Question number 6. Given f of x equals 2x minus 5, describe the transformation of the function. So I'm not real worried about this. This is not my problem. My problem is this right here. So let's just remind ourselves real quick of some of the notes that we did in class. We said that when you multiplied your function by a number and when you added a number to your function, things happened, right? That when you multiplied your function by a number, it either stretched it or compressed it, right? That was the deal. If you multiplied by something greater than 1, it's going to stretch it, right? If you multiply by something bigger than 1, it's going to make things bigger. So it does a vertical stretch of your function. If you multiply by something that's less than 1, between 0 and 1, by like a half or a third or a quarter or something like that, if you cut something in half, you're not stretching it, you're compressing it. You're making it smaller. So remember that. And then, of course, you guys did so well with this in class, that plus when we added or subtracted a number to our function, that meant that it shifted it up or down. And actually, we're going to use the word translate because that's the official word. We can say shift or slide, but we'll use the word translate. So it translates it up or down. So looking at our situation here, I am multiplying by 4. That's greater than 1. So it's going to stretch my function. So I'm going to say it's stretched, and I'm going to be nice and specific, stretched by a factor of 4. So I'm multiplying by 4. It's going to be stretched by a factor of 4. And, there's a minus 6 on the end. So is that going to translate up or down? Well, if I'm subtracting 6, it's going to go down. So we'll be nice and specific here too. So stretch by a factor of 4 and translated down 6 units. You also could have said it was shifted down 6 units or it slid down 6 units. I'm using the official math term, translate. Yeah, there you go. So this didn't even matter. This guy up here didn't even matter to us. If I want to describe the transformation, all I care about is what's happening down here. Yeah. This original function got stretched by a factor of 4 and translated down 6 units. Yep, there you go. Ooh, this is where life got interesting. Okay. Write the equation of a line that passes through the point -2, -3, and is parallel to the line y equals 4x plus 3. Now, there's more than one way of solving these. I'm just going to show you the way that we've been doing in class. It's not the only way. I'm just saying. First of all, I see the word parallel, and my thought is, oh, parallel lines have the same slope. So if it's parallel to this line, I need this guy's slope. This guy's slope is 4. So if it's parallel, my new slope should also be 4. Problem is, to write the equation, I need the y-intercept because I don't want that guy's y-intercept. I need a new y-intercept. So I don't want that 3. I'm just going to toss it out for now. In order to write the equation, write y equals mx plus b, I have the slope, but I need the new y-intercept. Now again, there's a couple ways of getting there. I'm going to show you what we've been doing in class. We used this point, right? We have a point, that's our x-coordinate, that's our y-coordinate. And I used my formula, my y equals mx plus b, to plug things in to find my missing y-intercept. I have a number for y, right? I have a -3 for y, so I'm going to put that there. Equals, we know the slope. We found the slope earlier. The slope is 4. And I'm going to multiply that by my number for x, which in this case will be a -2. And then we have plus b because, again, the problem is I don't know b. I don't know my y-intercept. That's the issue. So let's clean this up just a little bit. 4 times a -2 is, of course, -8. I'm going to go ahead and add 8 to both sides to get my b all alone. And -3 plus a +8 gives me a +5. Oh my gosh, check it out. We have a slope. We have a y-intercept. I can write the equation y equals 4x, since that's my slope, plus 5, because that's my y-intercept. And there is the equation of the line that's parallel to this line and passes through that point. Awesome. Very similar to it, but with an important difference, is question number 8. Question number 8, again, write the equation of a line that passes through the point 10, -1, and is, perpendicular to the line y equals 5x plus 1. Now, this one's a little trickier because perpendicular lines don't have the same slope. Remember that the slopes of perpendicular lines are opposite reciprocals. Remember this? Please remember, you have to change the sign and flip it. Positive becomes negative, or a negative becomes positive. 3/2 becomes 2/3, right? Both things have to happen. So I'm taking a look. This guy's slope is 5, and I'll even make it 5/1. So if that's a positive 5/1, my perpendicular slope needs to be, instead of positive, negative, and instead of 5/1, 1/5. There's my new slope. But again, to write the equation, I need a new y-intercept. I don't want his y-intercept. Go away, +1. I don't want you. I need a new y-intercept for my perpendicular line. So fine, let's plug in what we know. I have an x, I have a y, I have an m. Let's plug them in. So instead of y, I'm going to plug in -1. Instead of m, I will plug in -1/5. Instead of x, I will plug in 10 plus b. So this really is like what we did last time for the last one. I just had to do something different with the slope. But the same idea. Now, before you freak out over fractions, before you go, oh my gosh, how do I do fractions on my calculator? You don't need that. You don't need that. We've talked in class about the trick. Remember that you multiply with the top and then divide with the bottom. All right? 1 times 10 is 10. And then we divide by 5, which is 2. I am going to point out this was a negative 1/5 times a positive 10, so that's a negative 2. Again, 1 times 10 is 10, divide by 5 is 2. Still have my negative 1 here, still have my plus b. Oh, we're so close. I'm going to go ahead and add 2 to both sides to make that go away so that my b is all alone. Negative 1 plus 2, that's a positive 1. Yeah, negative 1, positive 2, negative 1, or positive 1, haha. Hey, we have a slope. We have a y-intercept, which means we can write an equation. So y equals negative 1/5 x plus, in this case, plus 1, because that's what my b value is. Woo, good job, us. We rock. Yay. And we didn't even panic over the fractions. Those fractions thought they had us. They didn't. This one gets a little messy, but it's nothing we can't handle, okay? Are you ready? Are you ready? I may just use a different color here for a bit because I think it'll make it a little easier. So we're going to use the functions f of x and g of x to complete the comparison statements using less than, greater than, or equal to. Please remember, alligator eats the bigger one, all that good stuff. But that means I need to know what each of these values are. So let's work our way through that. F of 3, that means I'm going to plug in a positive 3. There's 3, right? 3 is right there. So if I plug in a 3, and I'm going to, whoa, that was really badly done. If I plug in a 3, and it hits my line right there, so if my input is 3, my output, and I know that's hard to see, but that is a 6. So it looks like F of 3 is 6. Awesome. G is easier because I have a table. So G of 3, here's my 3. So if I input a 3, I get an output of 8. Awesome. Well, 6 is less than 8. Answer that question then. All right. Slope of F and slope of G. Oh, we got to find slopes. That's okay. We can find the slope. You just need 2 points, right? If you got 2 points, you can find the slope. Look, I have a point right there. There's a point. That's at what? Negative 3, 0. I've got another point up here. That point is at 0, 3. And so let's find the slope of this guy. So if I subtract my y's on top, 3 minus 0. Subtract my y's on top. Subtract my x's on the bottom. 0 minus a negative 3. Ooh. Can you please remember that we don't do minus a negative? Can you please remember that that's actually 0 plus 3 because minus a negative becomes a positive. And I now have 3 over 3, which is 1. So the slope of F is 1. Great. Slope of G. Whew, I need 2 points. I don't care which 2 points you pick. Pick 2 points. I'm going to pick this one and this one because they seem fewer negatives. I just don't want to deal with the negatives. I'm going to go ahead and find the slope here. So I will subtract my y's on top, 8 minus 2. I will subtract my x's on the bottom, 3 minus 0. 8 minus 2 is, of course, 6. 3 minus 0 is 3. 6 divided by 3 is 2. Wait, the slope of G is 2. So the slope of F is less than the slope of G. Fine. Last but not least, the y-intercept. The y-intercept of F, we already found that. There it is. The y-intercept of F is 3, right? It hits my y-axis at 3. We already found that one. The y-intercept of G, we said that's where x equals 0. So there's where x equals 0. And when x equals 0, I get a y-intercept of 2. Oh, so the y-intercept of F is actually greater than the y-intercept of G. All right then. I see how it is. We're almost done. One more problem. Alejandro and Maria collect movies. Maria's movie collection is shown in the graph. She started with 0 movies and added the same number of movies to her collection each month. In the 5th month, she had 15 movies. I'm going to make a note of that. So this must be month number 5. And if this is 15, so I'm going to make a note of that. This is months. This must be movies. Sorry, I can't write sideways on my tablet very well. If this is 15, then that's probably going to be what, 16? So it looks like we're going 4, 8, 12, 16. You get the idea here. Alejandro's movie collection is given by a description. So here it is. Alejandro started his collection with 27 movies. He inherited from his uncle and continues to buy 2 movies each month. Great. Compare the slope and the y-intercept for each function in terms of the quantities. That's kind of code for units, all right? You've got to give me units. So let's start with those slopes. So let's see. Maria's slope. Well, we know slope is something per something. And we know she started with 0 movies. And she ended up with 15 movies after 5 months. So I have a point of 0, 0. I also have a point of 5, 15. So if we were to do a little bit of work here for Maria, we would have 15 minus 0 over 5 minus 0, which is 15 over 5, which is 3. But don't forget your units. It's 3 what? 3 movies per month. So Maria's slope is 3 movies per month. Well, that actually then helps me find Alejandro's slope if it's movies per month, right? So if Maria's slope is 3, that means Alejandro's slope is 2. Look at that. There it is. Yeah. Alejandro, I see those movies each month, right? So Alejandro's slope is 2 movies per month. Awesome. Oh, so we've done the slope. I'm going to use another color here because we also have to do the y-intercept. Yeah, so let's talk about the y-intercept. Now, we've mentioned before on a graph, you can just look at where it hits the y-axis, but we've mentioned before that the y-intercept is how much they had to start with, right? This is how much they started with. This is the deal, right? Month 0, how much did they have when they started? Well, check it out. Maria started with nothing. She started with nothing. Okay, fine. So Maria's slope is 0 movies because she started with no movies. Fine, that's easy enough. That helps us then. That actually helps us with Alejandro as well, right? Because it says Alejandro started his collection with 27 movies that he inherited from his uncle. So that means that, I wrote slope. Bad, Miss Scott, bad. I shouldn't have written slope. I should have written y-intercept. See, even I make mistakes sometimes. So we're going to try it again. Maria's y-intercept, this is better, is 0 movies because she started with 0 movies. Do you feel better now? Sorry about that. I hope you feel better now. Alejandro's y-intercept, I almost did it again. Alejandro's y-intercept is 27 movies because that's how much he started off with. He started off with 27 movies. Boom! And there you go. Use another color here. Circle my answer. Be like, here's my answer. Good job, me. So Maria's slope is 3 movies per month, and Alejandro's slope is 2 movies per month because that's how much they were collecting each month. Maria's y-intercept is 0 movies, and Alejandro's y-intercept is 27 movies because that's what they started off with. So we've got our slopes, we've got our y-intercepts, and we've mentioned the quantities. So Maria is collecting a few more movies per month, but Alejandro started with more at the very beginning. So good for him. Hope you found this helpful. Hope you found this useful. If you got questions or concerns, come talk to me. I'm here to help, and I'll see you guys soon. Bye.